Right. So, in this lecture, we are going to examine several applications of generating random data with NumPy. The first application we want to examine refers to the following. When real data isn't available, we sometimes need pseudo-random data to test how well a program performs. Such application of random data is called test creation. One way to achieve this is by using NumPy arrays. We'll begin by generating 5 different 1,000 element arrays before creating a bigger array with all of them in it. Then we'll export that array into a separate CSV file, which can be used for testing. For each column, we'll need to store the values in a variable. We can name these variables array column 1, array column 2, and so on, so that we know which one is which. Since we already know how to generate data from a known probability distribution, you can choose any methods you prefer and pass whatever arguments you seem fit. In the interest of time, we're directly pasting the 5 rows of code where we generate the data. As you can see, we've opted for 2 normal, a logistic, an exponential, and a geometric distribution here. For each method, we've tried assigning different arguments to ensure our data is more varied. However, the common theme here is the size argument, which is set to 1,000 since we want all the columns to be of equal size. Fantastic! Now that we have our columns, let's use the NumPy function to create an array that will hold all the data. We'll call it random test data and set it equal to np.array. Then, in the parentheses, we'll input a list with all the different column variables we defined earlier. To make sure the dataset looks like we'd expect, let's display it on the next line and run the cell. We see that the random test data variable consists of 5 rows with 1,000 columns rather than the other way around. This isn't what we're looking for, so let's transpose it. For anyone who doesn't remember or know what that means, transposing a matrix is the act of transforming rows into columns and vice versa. Lucky for us, ND arrays are equipped with a method called transpose, which does exactly that. Hence, let's just add .transpose after the NumPy function and rerun the cell. The output shows an array with 5 columns and plenty of rows. Currently, not all of them are visible, but after calling the shape attribute of the array, we can see it holds 1,000 rows of values, which is exactly what we wanted. Great job! Now that we have our data set, we can save it to a CSV file. We can use NumPy's save.txt function to do this. We select the name of the file, the data set we want to store, the format we want it saved as, and finally, the delimiter. If we've set everything up correctly, in the directory of the Python notebook we're currently running, there should be a CSV file titled Random Test from NumPy. To test its content, we can go to the directory and use a text editor to view it. Alternatively, we can import the newly created CSV back into Python and display its contents. Let's go for the second option. To make it happen, we can simply call NumPy's generateFromText function and add the file name and delimiter as inputs. It's pretty clear to see that the output here is the same as the output from the last cell. So we've successfully managed to create an entire CSV file we can use to test future programs. Superb! Wasn't that exciting? After having a more in-depth look at the application of generating arrays of random and non-random data, we're ready to move on to an entirely different topic. In the next section of the course, we're going to take advantage of NumPy's computational power and examine the various statistical functions it contains. Thanks for watching.